In this video, we're going to take a look at how we can calculate slope just from two different points. So before we get to that, we're going to quickly recap initial value and rate of change from tables of values and graphs. So the initial value for the relationship that we see here in this table of values and this graph over here, the initial value, so remember that happens when x equals 0. So I'm going to find when x is 0, and that's not the initial value. I'm looking for what is the y at that point. So the initial value here is 0 for this relationship. The rate of change, is that a positive or negative? So remember, we can find the rate of change by using the first differences. So over here we have -3 subtract -6. So subtracting a negative is the same as adding, so -3 plus 6, and that's an increase of 3. From 0 to -3, so 0 subtract -3 or 0 plus 3, also 3. 3 subtract 0, and 6 subtract 3. So these are our delta y, or our change in y, and we can see as we move along the x's that each time we're increasing by just 1. So the rate of change here is 3 over 1. Both of these values are positive, so overall this is a positive rate of change. And the rate of change here is 3 over 1, or just 3. And it's a positive 3, but if we just write 3, it's automatically positive unless we were to put a negative there. Remember, we can also do it from a graph, so I can find some points. So we have a point here at 0, 0. There's another one here at 1, 3. There's one here at 2, 6, and so on. So we can pick any of these points. So I'm going to go from here to here. So my rise here is up 3, and my run is 1, and slope is equal to rise over run, or 3 over 1, which is equal to 3. So these are two different ways that I can calculate rate of change, by doing my delta y over my delta x, or counting my rise over run. And then the initial value I'm going to find in my table when x is 0. What is my y amount? I can do the same thing over here. So x is 0 over here, or the y axis is crossed over here by this graph. So I can also from here see that my y value on here is at 0. So the initial value can also be found either on the graph or from the table of values. So what we're going to take a look at is that I don't actually have to go through and find first differences between all of the points in a table of values. I can actually figure out the slope from any 2 points, because the slope is constant. That steepness of the line and the direction it's going, whether it's positive or negative, is the same the whole way through for a linear relation. So what we're going to do is we're going to take this table that has 5 different points. We've just labeled the points to help keep track of what points we happen to be talking about, but we're just going to pick 2 points at a time, and we're going to see what happens when we calculate slope from just those 2 points. So point 1, I'm just going to quickly do some coloring here to help us see what numbers we're using. And then point 3 doesn't get used anywhere, so I won't bother with that one. And point 5. Okay, so the first set of points I'm going to use are point 1 and point 2. So point 1 is -2, -1, and point 2 is -1, 1. So to calculate slope, slope is equal to delta y over delta x. So my change in y, I'm going to take the second value, so the 1, and I'm going to subtract the 1 that is above that. So remember, we were doing 1 subtract negative 1. So that gives me my delta y, and that is equal to 2. And same thing over here to find my delta x. So I have negative 1 subtract negative 2, which is equal to 1. And 2 divided by 1 is equal to 2. So here I have a slope of 2. So let's take a look at what happens when I use different points from my table. So this one uses points 1 and 5. So we have negative 2 and negative 1 again. So in the first one we used 1 and 2. We're going to use 1 still, but this time we're going to use 5 as our second point. So over here, my delta y, I have 5 subtract negative 1, and my delta x, I have 2 subtract negative 2. So my slope is delta y over delta x. Delta y, 5 plus 1 is equal to 6, and 2 plus 2 is, oh, what did I do here? I made a mistake. Yes, I did. This is 7, not 5. And that will change this. So we have 7 subtract negative 1. Sorry about that. So 7 plus 1, that's 8. And then over 2 minus negative 2, or 2 plus 2, which is 4. And 8 divided by 4 is equal to 2. So my slope is 2. So we ended up getting the same slope using different points in the same table. Now let's try with points 2 and 4. So a different set of points, negative 1, 1, and 1, 5. So let's try with these ones. So we have 5 subtract 1. So that's my delta y, which is 4. And over here, I have 1 subtract negative 1, or 1 plus 1, which is 2. And 4 divided by 2 is equal to 2. So using these 5 points, I picked 2 different sets of points 3 times, and every single time my slope is equal to 2. So what that tells us is that we do not have to go through this every single time. We can actually just pick any 2 points, and we can calculate our slope or our rate of change from that. So let's pick another, or let's do another example here. We have a point A, which is 2, 1, and a point B, which is 7, 6. And I'm going to plot these 2 points. I'm also going to write them in here. So we have 2, 1, 2, 1. Oops. There we go. And we have the point 7, 6. Which is over here. Okay, so we have a linear relation that goes through those 2 points. So let's take a look. Here I have 6 subtract 1, and here I have 7 subtract 2. So delta y over delta x is 5 over 5, and 5 divided by 5 is equal to 1. So that means I have a slope of 1. Now, if I want to add more points from either of these points out, I want a slope which has a rise and a run. Now this is a whole number, so that's a rise. What I want to see is, what would my run be? So 1 divided by something equals 1. Remember, it's when our run is 1 that we can have a whole number as our slope. So I'm going to use that to find my next point. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. We can continue that, and we can work backwards as well. Down 1 to the left, down 1 to the left. And you can see that we have a straight line or linear relation here. So we have a slope of 1 or a rate of change of 1. We had just the 2 points given to us, but once we had a slope, we were able to plot a bunch of other points. The next question we have here is, what is the initial value? So when our graph crosses the y-axis, that is where our initial value is. So when x is 0, and at this point my y is equal to -1. So the initial value of this linear relation is -1. So from 2 points, I was able to plot, I was able to calculate the slope from it, and then I was able to extend that line and figure out what the initial value is. For the next few examples, we're going to focus on just using 2 points and using a formula. So you can see here that each time I was taking the second y value and subtracting the first to calculate my delta y, and then I was taking my second x value and subtracting my first x value for my delta x. So that is all that the equation actually does for us. So the equation is that slope is equal to y2 minus y1 over x2 minus x1. Now when we have a set of coordinates, we always have our x coordinate first and our y coordinate second. So over here, point A has an x coordinate and a y coordinate, and so does point B. Now the problem here is that when I'm not putting those points together in a table of values like this, where I can very easily see the second point subtract the first each time, when I want to use this formula, I don't see that. And the problem here is these are both called x and these are both called y. So the 1's and the 2's in the equation are just to identify the x value from a certain point. So one of the things I like to do is I like to look at my x value and find which one is smaller. And this is the one that's smaller. So I'm going to call this one 0.1. So point B is my 0.1. So that means -3 is my x coordinate for 0.1 and -9 is my y coordinate for 0.1. So I'm just going to call that x1 and y1. And then for point A, this is going to be the second point that I use. My x coordinate 3 is x2 and my y coordinate is y2. So it's just the y coordinate of point 2. So that's all those subscripts 1 and 2 mean. Now, does this have to be 0.1 and does this have to be 0.2? Absolutely not. It doesn't matter which one you pick, but if this is 0.1, then this is x1 and this is y1, and this is 0.2, then x2, y2. The reason that I find the smaller number for the x and make that one my x1, so I'm comparing the 3 here and the -3, is that it makes sure that we have as few negatives to work with as possible. But either way, you will get to the correct answer. Okay, so let's try this out. Slope is equal to y2 minus y1 over x2 minus x1. So my first number that I want to do is y2, that's this one, -3. Then I'm going to subtract whatever y1 is, and that is -9. I'm going to put it in brackets because I have a double sign, I'm subtracting a negative. On the bottom, my first number is going to be x2, so that's the x value of 0.2, that's 3. And then I'm going to subtract whatever x1 is, and that is -3. So now I'm just going to solve my numerator and my denominator. So I have -3 subtract -9, that's the same as -3 plus 9, or 9 minus 3, which is 6. And then I have 3 subtract -3, or 3 plus 3, which is also 6. And 6 divided by 6 is equal to 1. So this gives me a slope of 1 between these 2 points. So if I said this was 0.1 and this was 0.2, I would just have my numbers flipped, -9 minus negative 3 and then negative 3 minus 3, it would give me negative 6 over negative 6. I would still have a positive 1 as my final answer, but I would have two negatives over here. So that is the only thing that finding the smaller x value to make it your x1, all it does is reduce the double negatives if those exist. But either way, your answer will be correct. Okay, let's try two more and then we are done here. So I have negative 4 for x here and 8 here. Negative 4 is a smaller number. So I have x1, y1, and then x2, y2. So slope equals y2 minus y1 over x2 minus x1. y2 is equal to negative 3. y1 is 6. So negative 3 subtract 6. And x2 is 8. x1 is negative 4. So 8 subtract negative 4. So negative 3 subtract 6 is negative 9. And 8 subtract negative 4 is 12. Now, it doesn't matter if you have a negative here or here. If you made this 0.2 and this 0.1, you'd have 9 over negative 12. What we're going to do is we're just going to put our negative there in the middle. So it's not going to be attached to either number, just the whole fraction. So we have a negative fraction here. Now, 9 and 12 are both divisible by 3, so I'm going to actually reduce this to lowest terms. I'm going to divide both of these by 3. So 9 divided by 3 is 3. 12 divided by 3 is 4. So my slope between these 2 points is equal to negative 3 over 4. All right, let's look at the next question. So I have 3 and 6 for my x's, so 3 is smaller, so there's my x1, y1, and then I have x2, y2. So slope equals y2 minus y1 over x2 minus x1. My y2 is 8, and my y1 is 2. My x2 is 6, and my x1 is 3. 8 minus 2 is 6, and 6 minus 3 is 3, and 6 divided by 3 is equal to 2. So my slope here is equal to positive 2 or 2.